The biggest challenge that manufacturing leaders and engineers have today is getting more output out of their plants at lower cost, less scrap, higher line speeds, less downtime. But it's quite a challenge. You think about how hard it is to go find information that you need. One of the deepest frustrations of manufacturing leadership is getting information when you need it without having to run around and try to hunt people down and get information that you need when you need it. Well, generative AI is starting to show a possible way to solve this. Generative AI has an ability to combine kind of the soft, fuzzy tribal knowledge of how to do things with an ability to understand the production data that exists in your operations, everything from production data, throughput information, cycle times, to sensor data and IoT information that you might have coming off of your production. We have a little something to show you that is a new system that we have developed that combines these two things, that it can look at the tribal knowledge of how things work in your manufacturing operation, but also give you instant access to all that manufacturing data and process data to help you be effective and to resolve problems, to increase output and lower costs today. Let's take a look. So we're going to look at an example here where we are looking into a problem with an extrusion line that we had, and we're going to get into the bottom of an issue that would normally take us quite a bit of time to resolve. Hey, we had an issue on the extruder and the extruder RPM. Can you give me the extruder RPM for August 13th? I actually want that week, so the Monday through Friday of that week. Can you get that for me? So you can see here, even though I've just spoken in the microphone here, it's picked it up. I haven't been incredibly specific with my request. The system is able to understand what I want. I don't have to say things exactly a certain way. It understands that I want the Monday through Friday of that week, even if the 13th was not actually that Monday. And you can see the AI thinking through here what exactly it was that I wanted. You can actually see the AI considering the request, thinking about what it knows, and executing queries against the data to be able to self-reflect about to solve our problem. And that allows it a level of flexibility that's just unprecedented with traditional interfaces. And so here it's gone through and fulfilled our request. It's gotten us this extruder RPM data for that week from Monday through Friday. Now, by the way, you can download this information in a CSV really easily right here. So if you want to do further analysis on it, you can. So we've got our data here, and we can see that it's a little bit noisy, but we see that it goes to zero on the 16th. So let's have it zoom in a little bit. Hey, can you zoom in on August 16th there? It looks like it declined. August 16th, so we can see that particular day's data a little bit better. Again, it's going to go through here, evaluate everything that we've asked for. Then it pulls a report from the database and then pulls this analysis that we can look at right here, and we can actually look at exactly when something happened. Now, here's where it gets interesting. So now that we know that this extruder stopped working sometime on the 16th, well, maybe somebody put in a work order for it. Let's find out. Hey, was there a work order put in on the 16th for the extruder? So now we've asked for the work order. It's going to search for any results from that, and it looks like it's found one. There we go. We see that pulling up from the work order here, it has discovered that there was a work order entered here, and we see that the a fan died and a motor controller kicked out. Well, that's interesting, but now what if we search through our tribal knowledge to see if this has happened before and what we could do about it? That's interesting. Search our documents. I want to know if this has happened before and what to do about it. Now it's going to be looking through all the history of maintenance work orders and knowledge and documentation that we have put in the system over time that might be possibly related to this, that could be causing a loss of RPM based on that work order. And here we find out it's using a mix of some third-party information and also telling us from our own work orders that it looks like that we might have some issues with fans. We got to take a look at fan wiring. These are actual work orders that have happened in the past that have caused these motors to overheat. And we can look through all these options to tell us, well, it looks like this has happened before, and we can actually go through and see all the times that it has happened, times from years ago where this particular issue has happened, and then use that information to give recommendations to us to be able to fix it. So we're seeing that merging of that tribal knowledge of what has happened over a decade plus time span together with the analytics coming in from your factory operations. Well, let's take a look at some more information. Let's actually find out. Let's find out when that machine came back up. Well, so can you look at the day, August 17th? I want to know when that when the extruder came back up. So we know on the 16th that the extrusion line went down because RPM meters went to 0. Now we've just asked the AI, we want to know if it came up on the 17th, and if it did, we want to know when it did. Again, you can see the AI thinking through our question. We're not using precise language. We're not having to tell it exactly the name of the sensor, the name of the data series, anything like that. But now let's look through it here and we see, oh, we know exactly when it came up. It looks like it was about 5:30, just before 5:30 in the morning on August 17th. So we have our exact answer there. Now let's take a look at how we can use this ability to build data in this dynamic way to be able to get increased output. We'll use an example with injection molding. Histograms are incredibly useful to be able to see how we can achieve the best, and whether what our team is telling us is the best that they can do is actually the best that we have done in the past. Fantastic way to look at it. So let's take a look at that example. Can you give me a histogram of the SR350 mold of cycle time, please? So here, again, it's going to figure out, what is this mold that we just said? We don't have to say it specifically because it recursively thinks about it, searches through, and figures out what we're actually talking about. So it's a very fuzzy thinker that way. And now it's preparing a histogram for us so that we can look at the distribution of cycle times that we have achieved. Now, think about what this means. You might have a team coming to you and say, hey, look, we can only do 7.7 seconds. That's the very best that we can do. Now, you can pull this up on your phone. You can pull it up on your desktop and say, well, actually, it looks like we're normally more at like 7.2 seconds. And by the way, we've also performed at 6.7 seconds. So what's preventing us from going from that higher number down to that lower number and getting a little bit more performance out of this? Now, see, we've got some outliers here. One of the fantastic things about this is that we can just recursively ask the AI to eliminate those outliers. So let's do that. That's great, but can you take out the outliers, clip the outliers on that? So now it's going to go back and it's going to rerun this analysis. It's going to figure out what we're talking about. And it has a question for us. And it says, how do you want to do it? Well, let's just say, just do the clip off the bottom 5% and the upper 5%. So you can see when it wants some clarification, it just asks us for that. And now we're going through and it is running that histogram. And it tells us that it has removed the bottom 5%, upper 5%, and now we've got that histogram again, but it's clipped off those outliers just like we asked. Now, this is kind of interesting, but maybe we want to know, this mold can perform differently by machine. So let's tell it to get some data for that. Okay, that's good. I want to know now what the average cycle time for that mold is by the machine that it ran in. Give me that for me, please. It's pulling that data up for us. Again, it's thinking through, making sure it's got the exact mold name for us. And then it presents us a table of each of the machines that it ran in. And we can see in a chart and in a table. And again, we can download this if we want to do further analysis on it to see exactly what that looks like. Okay, let's take a look at one more example here. And this is just shows the power of the kind of charting that it can do completely generated by generative AI. Okay, I'd like a scatter plot of the cycle time of the SR350 mold over time, and I want you to color it, color the points by the machine it ran in. So again, it's going to clarify what mold we're talking about. We've given it a somewhat complex request here, and so it's going through this data. It is learning which mold that we're talking about. It's figuring out which machines it ran in so it can prepare this data request. and then it's executing the database queries and pulling in the data so it can prepare a chart for us. And there we go. We've got the chart of all the times that it has ran, and it's colored it by the machine that it ran in. Let's take a look at another example of how we can pull in, machine data. If you've got a quality problem off a particular molding machine and there's some bad parts produced, and you want to understand what was happening at the time that that part was produced, well, now you can use generative AI layered on your IoT data coming in from your machines to give fresh insights so that you can pull that up extremely quickly. And again, this works on the cell phone, works on a tablet, works on your desktop, works in the cloud as well. So let's take an example of that. Can you give me the hydraulic pressure of cell 1? I'd like it over last week, please. So now it's going to take our request. It's going to figure out what sensor we're probably talking about. You can see here it's already figured it out. And then it's going to figure out what data request, what time request we want. It's figured that out as well. And then all of a sudden we have here our request for the hydraulic pressure. So if we know that we had a issue later in the week, we can see that the hydraulic pressure on this machine has dropped steadily throughout the week. So maybe we had an issue with underpacking, or we had some other problem that came up with parts later in the week. We can just quickly pull that up in seconds, have answers for what could be driving these scrap issues. Now, this can be plugged into any of your production data. So imagine this with your scrap data, your cycle time data, your parts produced per shift data, your uptime data. You can plug it into hydraulic transducer, pressure transducers. You can plug it into thermocouples to get temperature readings over time. Any kinds of data that you have, whether it be ERP production data, like inventory data, for example, or whether it be sensor data, you can use this to give you fresh insights in just seconds by the AI interpreting what you need and using that to be able to get the data that you need to be able to make the executive decisions out on the plant floor.